I have to actually be more of a stringent time because now we're actually already running over time. So next we've got 2 more presentations and then the show and tell. So the first presentation for the second half of this evening will be Barlett and Matt, who I believe are ready. So, yeah.
We just forget one minor glitch at the last second.
Okay.
All right, let's do it. Just
yeah. Okay. Cool. Thank you.
Good evening, ladies and gentlemen. My name is Barlett.
And this is Matt. Hi.
And we're going to take you on a brief tour through some of the cool things you can do with radio, specifically software-defined radio. This joke got me into it a while back. Actually, not that long ago, funnily enough. Because of this sort of stuff we've been looking at.
It's actually a bit of a drug addict tactic. What I did was I got my software radio box and I lent it to him for about 6 months, and he started coding, and just as he dropped out of his PhD to start working on software radio, we did the original Dorkbot presentation in October 2010, and just as he was hooked, I took it off him. And he went through the most massive withdrawal symptoms, and I was the worst person in the world, and I gave it back to him, and he's been addicted ever since. So this is sort of the result.
I hassled the company to send me one for free.
Well, I gave it back to you, and then we did that, but anyway, that's another story.
So we'll try and make it technical and fun.
And also, please ensure your seatbelt is upright and your tray table is stowed. This is very heavily aviation slanted, and we've done quite a bit of hacking on aviation radar, so we hope you guys enjoy it.
Let's just take a step back. Can I have a show of hands of who would have seen this or has used the Australian Geographical Radio Frequency Map? I've shown it once at Dorkbot many years ago.
Okay.
All right. It's a mashup that's publicly available on the internet that shows you where every single radio transmitter is in the entire country. So you can search it, you can look at the entire country. This is a visualization of every transmitter and every link between every transmitter, and underneath is the terrain data from the Space Shuttle topographic mission. When you zoom in, all the individual sites come up. If you've got many in one area, they get clustered. If you have a base station for a mobile carrier, then that's indicated by the logo. If you turn on the links layer, then you can see how they're all connected because they send information between one another, especially in these sorts of remote areas, and you can get some pretty visualizations of the terrain data as well. This is the entire country using the NASA data. When you actually click on a site, then you get the information about who is actually based there. You can see here you've got some Vodafone assignments, so Vodafone obviously runs 3G out of the cell because the frequencies are such. And you've also got some aviation-related frequencies, and we'll actually be delving into these a little more later on. This is our Sydney Harbour Bridge. If you click on the Telstra one, you can actually view comparatively what the radiation pattern is for an antenna on there, so you can see kind of which way it's pointing. Also, if you want to explore the links a little further, this one's a Bureau of Meteorology one, and if you click on the link, it'll show you which site it connects to. Click on the link itself, and it'll take you to the other site, and there you can see the bomb on the other ones. This is actually a visualization of every single base station which is operated by our favourite 3 carriers. This is all of them. That's Telstra, that's Optus, and you can guess. There's also this search facility that I built in, and this is actually showing you all of the cell sites and then all of the new cell sites that have been installed or upgraded since late last year. And these are obviously the Vodafone ones, and they've been working very heavily in the metro areas to improve their coverage, as you can see here.
And actually, Vodafone sort of headhunted Barlett because he was doing a bit of positive PR based on the network improvements that had been done at the time. So, yeah, it's sort of a bit of a hobby, but it also gave them a bit of a positive spin too.
If you take the antenna information, you can actually visualize that as well. This is one single antenna, but if you apply that to, say, my neighborhood, you get something that looks like this. So these are all of the sites. You've got Optus, Vodafone, Telstra, a bunch of other things, and you can see sort of how the radiation is emitted around your area. These little markers there are actually the amateur radio operators as well. They're on the map. These are all of our hams around the country. And this is Sydney, and that's me there. So I get all my assignments. Matt would just be a little Actually, I need to update it because you're probably still reading.
I'm not on there, yeah. Under the radar.
It also collects information about who's visiting and what they like to look at. Interestingly enough, I think thanks to Aras, or rather his alter ego or alternate friend on Reddit, the ones in number 2, 3, and 4 are actually the secret defense installations that are part of the Echelon network. So this is
the Echelon stations.
This is Kojarina. If you actually click on these assignments, then they're actually really generic. So all of the secret good stuff, unfortunately, is not in the public database. This is good old Pine Gap, and it's just got a single assignment. I'm sure there's a lot more going on in there that we're not privy to. And
yeah, this here is a rather crazy sort of radio installation we've found up in the Northern Territory. It puts out some huge amount of power, something like, 20 megawatts or something astronomical, is it? A huge amount of RF coming on. You can actually click on links and find out. But what's interesting is that there's been 4 separate aircraft, commercial aircraft, flying over this region that have had their autopilots go completely crazy. And you'll probably remember one of them, it was an Airbus A320, and the computer completely went nuts. The aircraft went, it was Qantas Flight 72, the aircraft went straight up, it pitched up, and then it went straight down. No one had their seatbelts on. Everyone hit the roof of the aircraft, and then they basically hit the ground, and people broke legs, and all sorts of crazy stuff happened. But it's just a slight theory that we had one night talking on Skype, and because of the huge amount of power coming off that site, and given that all those upsets have happened in the general area, there might be some sort of harmonic radiating off that somehow interfered with the airplanes, but, who knows?
Purely speculative.
Yeah, it's just a guess, right?
Okay, side note. When I initially launched RFMap, on the first day, the US Department of Justice, the New South Wales Attorney General's Department, and Parliament House all had a look to make sure that it was legit and that I hadn't broken into some government department and stole some sort of sensitive data and then decided to spend, weeks and months
making it public,
making it, mash up and make it publicly accessible. A little while later, some hackers tried to get in and scrape up all my data and muck around with it. I did a bit of investigation, turned out they were from Bolivia, and since then, the entire country has been... So, yeah. Now, moving right along, the sense here that we want to try to impart to you is that there's a lot of things going on over the airwaves, and it's really all for the taking if you've got the right hardware, which is quite accessible now. Some of you might remember that I did some work on hospital pager systems, so this is a very quick review of the sort of process you go through from first principles. I tuned my radio in and I heard this.
Or maybe you didn't.
Did it plug into this?
I plugged it in. Okay. And I thought, I'm going to make it my mission to find out what that is. The interesting thing was that the rate at which these messages were being transmitted changed throughout the day. So there's a clear correlation with human activity there. This is a setup I was receiving the signal with. My very first computer, a 286, took in the audio, sent it across the network, and I would analyze it later. This is the kind of frequency and time domain analysis you can do. You can see there are clearly 2 levels here. And you can slice that to get ones and zeros, your binary raw data. The first bit, and we'll come back to this later, is called the...
preamble, yeah. You basically got the preamble, which is a synchronization pulse. In any communication system, you've got a receiver and a transmitter. The receiver doesn't know what it's listening for, so it's looking for a set pattern. And when it detects that set pattern, it uses that to calibrate itself, given the certain parameters used for that transmission. So that noise that you heard at the start, where you got the constant tone, that it uses that to determine what's a 1 and what's a 0. And then the receiver is trained to that frequency, and then you can basically use that information to detect the payload, which is where all your data is.
Create a bit of a program to decode that data, and it generates a pulse train like that. You got ones and zeros, great. Now the hard bit comes where you actually have to turn that into some intelligent information. This actually took 5 years. There's a bit of a break in the middle. But I was hunting around. I thought, hang on a minute, I recognise those numbers. I was reading an article, and these magic numbers popped up. And this is what you kind of have to do. You have to read very widely, and then keep it all in mind and draw the dots together.
Not your average person wouldn't recognise those numbers. It's just this guy.
So it turned out to be pages, and it actually turned out to be coming from the Royal Prince Alfred Hospital. and they use them there because the penetration is far greater than what cell phones can get. And this is actually what it looks like on RFMap if you were to put it in. This is RPA, and these are actually the frequencies. This is the standard pager frequency. Normal software can pick this up, but when I tried it with the normal software on this other frequency, it didn't work. So they changed something. It's called security through obscurity, but you can crack it. And these are the special ones. So it's all there. And if you actually look at the links that are related to that pager system on RFMap, it actually links to all of the other major hospitals, or all the hospitals in the Sydney West Area Health Service.
Except for ye old Camden, it's kind of off by itself down there in the corner.
Maybe it's out of that group.
True.
And if you look a little closer at these numbers, you can actually relate to individual hospitals. And this is the kind of information you can glean from that. Moving right along, let's talk aviation and how you can apply these techniques to it. We have a kind of nickname. There's a technology called Mode S, but because we love it so much, and there's an ambiguity with S on the end. Sounds like a plural, so we kind of twisted that into modes. So I'm obsessed with modes. You like it too.
Yeah, it works. Yeah.
I have to give attribution for this photo to a friend of mine, Oscar Delelis. I thought it was quite a stunning photo, and I had to use it. This is me on a domestic flight. I figured, well, I'm going to blue tack a GPS to the window and see what I can do with it. The hostess or the stewardess
went nuts.
Well, no, that was the flight mode on the phone. He just made sure in this instance that it was off. And of course, I'd blanked the screen and it was running the entire time. That's actually nothing, because I went to Melbourne recently and I was on 3G tethered to my laptop during takeoff trying to get this whole system working, but Optus let me down. Anyway, this is taking off. You can see that you're actually traveling quite fast and increasing in altitude. And if you chuck it into Google Earth with a recorded track, you get some pretty pictures, color-coded altitude there.
Does 3G work with the Doppler of 600 km per hour?
Well, by that time, it probably would have been too late. This was on takeoff roll.
So we'll give a little bit of background on radar, because I'm the aviation expert. He's the software guy. I'm the lunatic hardware guy, kind of. And in my spare time, I actually have a private pilot's license. So that's where the initial interest came from in this technology. So going back to original first principles for radar, you've got two different types, primary radar and secondary. Primary radar is the original one that was invented back in World War II. And it basically works by sending out a really, really, really strong signal. That signal hits the metal of an aircraft, which then reflects it back to the receiver. So it's essentially like shining a flashlight in the darkness and sort of seeing if you can see what's out there. If you can see a reflection back, you know there's an aircraft there. The second type is secondary surveillance radar. They put some smarts into it to actually talk to an aircraft. So you'll send a pulse out to the aircraft aircraft's transponder will read it, and it'll send a coded response back saying, hi, this is my code, my altitude, this is who I am, and this is where I'm going and what I'm doing. And that's called secondary surveillance radar. That's the top array up there. That's the one that we're interested in for the purposes of this project. Essentially, there's a lot of limitations for primary radar. It's limited by power, range, noise. It's not very useful. Secondary radar is much better. You need a transponder on board, which is more expensive and it adds complexity and whatever, but it makes the system a lot more flexible. At Sydney radar, basically this here is at Sydney Airport. This is on RFMap and it basically shows these allocations. And the two that we're interested in, it's the 1 gigahertz and the 1.03 gigahertz. They're the ones we're actually listening to. And the primary radar is that one there on 2.85 gigs. So
that's called SkyPaint. That's the really powerful thing that turns around and transmits the pulse out.
It's the flashlight. It's probably one that will give you cancer if you stand too close to it for too long. And you can see it's putting out a ton of power. So that's essentially the range, I think.
Well, I think the range is bigger than that. But remember, this is only comparative illustrations. But, if you compare that to the little triangle off the Sydney Harbour Bridge, it's
a lot bigger. It's basically that the purple area gives you an idea of what the power density is like of the transmitter. So, that's the transponder I was mentioning. In this instance, the guy's squawking 2462. So, basically the radar guys that are on the ground at Mascot, they can see that 2462 is the actual aircraft that's been assigned that ID. There's Mode A, which replies with that code only. There's Mode C, which replies with that code and the altitude of the aircraft. And then there's Mode S, which enables some really funky stuff called ADS-B. And that's what we use to kind of hack it up and look into Google Earth.
The important thing, if I may just to bear in mind, is that if you're using primary radar and you've got your radar turning around, you've got your scope, you'll see blips, right? But the whole idea is that you want to know which blip is actually which aircraft, and that's why you have the mode A transponder, because that primary radar system will give you the blip, but the secondary system will also ask it for the code. So when you're looking at the scope, you'll see the blip and a code on it. So it basically tells you which aircraft is where.
You're looking at, yeah. So yeah, that's basically Mode S. ADS-B, which is an extension to Mode S, this is where it gets really intelligent. It stands for Automatic Dependent Surveillance Broadcast. And it's basically a broadcast because the aircraft is sending the message out to all and sundry. It's not intended for the radar guys back on the ground. The message is going out there to other aircraft, the controllers on the ground, and anyone with like a radar box that can actually intercept these signals, and over to Ballant. So yeah, as you can see, the yellow line there represents the fact that it's broadcasting. The things that it's broadcasting are position, heading, altitude, the vertical rate, so you know if it's going to crash. The flight ID, which is the same as what you see on your ticket when you book, VOZ 387, that's Virgin Australia, flight number 387, and the squawk code, which is similar to what we just saw. ATC basically sends out a pulse. Basically, the transmitter can be anywhere, can be remote, or actually at the airport.
So it doesn't need to be that thing on top of the big rotating dish. It can just be an antenna.
It can be anywhere.
And you'll see that in a minute.
Yeah, so it basically sends an interrogation request. The aircraft receives it, and it talks back, and it goes, hey, look, this is my flight ID, this is what I'm doing, this is my speed, my heading, my altitude, and all that sort of information. It enables other features, too, for aircraft to talk to each other, so there's a little bit of intelligence in there. For example, the aircraft on the left has sent out an altitude request to the one on the right, and the one on the right's gone, hey dude, I'm 500 feet behind you, we'd better sort of negotiate a way around the situation because we're going to crash. So yeah, basically in that instance, when the two aircraft are ADS-B equipped, you'll know from like watching TV shows and whatnot, you get the little cockpit voice saying pull up, or turn left or turn right or whatever. So yeah, this is the Mode S sites in Sydney. You can see they're basically scattered all around the place. There's a cluster there around Sydney Airport, of course, so that it's they've got better coverage there. But you've also got one out here at Camden Airport, one at Holsworthy, Cecil Hills, and they're all around the place. So
we should also mention that TCAS stands for Traffic Collision Avoidance System,
yeah.
And ACAS is
Aircraft Collision Avoidance System.
Right. So
okay.
if we actually look into the guts of it, what's going on, these things are talking to one another, but how are they talking to one another? The Mode S transmissions, the replies and the broadcasts, these series of pulses that get sent out across the airwaves. The only thing to notice here is that the pulses are very, very short. We're talking, microseconds, so they're incredibly short. And that means that you need a really fancy radio to pick that up. This is not something you pick up on your scanner or your AM radio. You need a really high-speed radio. And that's where SDR comes in. This is everybody's favorite open source, open hardware designed, software-defined radio. Matt, do you want to talk a little bit about it?
Oh, yeah. It's called the USRP. And as its name suggests, it's the Universal Software Radio Peripheral. Most of you will be familiar with radio devices, say a mobile phone is a radio device, or a television is a radio device, or what's another example? Your laptop, like your Bluetooth connection, or your Wi-Fi connection. And everyone automatically associates the device with its purpose. What software radio does is it abstracts the purpose from the hardware. You've got a universal radio here. It's a massively powerful device you're only limited by your imagination and your ability to code software, which I can't do for shit, which is where this guy comes in. Basically, if you can code really cool software, you can do any type of protocol you want. This particular device has been used to emulate mobile phone base stations, aircraft radar. A second project of mine with a guy in Queensland, we actually hacked police radio and cracked their cryptography using the same technology. And that's what that there is. And my lawyer friend's shaking his head there because he knows he's going to get a call from the cops. So it's basically a universal radio that you can do anything with.
And it plugs in via USB.
Exactly.
Easy.
It's just like plugging into, like your memory stick or whatever. You can see there that, for you guys that are more technically inclined, you can see that it's very wide band. You can do anything from 50 megs to 2.2 gigs, which covers the bulk of RF spectrum out there. Here's Ballant's free one that he got from the manufacturer.
Didn't come in a case,
yeah.
So I put it in my own case.
So yeah, that's it. And as you can see, it's pimping. You go.
In comparison, if you want to get a slightly cheaper option, you can get one of these little things, plugs in, no external power, really, really handy, but it's in terms of its abilities, it's far less than what the USRP can do, but good nevertheless. In the current setup I've got at the moment, there are 2 of these and 1 USRP.
Just go. We're short. We're short for time.
So there's an open source toolkit you can use, which is absolutely fantastic, does lots of things, but I won't go into the details now. This is actually some programming, so you don't have to write code, you can just assemble it. And this is actually an AM radio, so instead of having a little crystal set or whatever, you can spend ridiculous amounts of money and then do this to listen to your favorite AM broadcast. You plug in your USRP there, you can visualize it on this display, and you can send it out to the sound card on your computer, and that's it. A little bit more fancy, this is actually the mobile phone spectrum, the 2G spectrum. This is a waterfall, so you have to imagine that it's moving up in time. And what's interesting is that you can actually see the individual channels there. This one's the broadcast channel that all the phones listen to all the time to get information about the network. And these are actually people talking. These are conversations happening here. They're called traffic channels. And you can just hook it up. And as Matt said, you can make your own base station and get everybody's phone to log on to yours, thinking that it's a legitimate base station belonging to Telstra or Optus or whatever. You can disable encryption and then listen to everybody's phone calls.
It's been done. It's been done.
Okay. Well, we wanted to do it now, but there's you can also take it out into the field and use it for other purposes. We're amateur radio enthusiasts, so we actually thought about trying to pick up people from the other side of the world using this equipment. And you can do that. This is, the 3 of us, the 3 balls are all here. And this is a long wire antenna connected to the system. And it's really cool because what you can do is instead of having that little dial and tuning and listening out for stuff, you can actually just look and see all of the hams transmitting and talking to one another, transmitting Morse code.
It's analogous to looking at every single FM radio station at once so you can see which ones are active. You can look and go, hey, there's a guy over there, I'm going to tune in over there, whereas you normally limit to listening to one channel at a time.
We went out the other night, set this up, and we were listening to the Chinese over the horizon radar system, and I'm going to try and do a bit of analysis on that. But this is just something to decode Morse code. So back to aviation now. This is actually the Mode S, what Mode S looks like on the waterfall. So as you can see, they're very wideband and quite powerful. This is a Mode S pulse. This is actually something that you receive. And if you look at that, like with the pages before, you've got the preamble, you've got the payload, and just visualizing how it actually looks. To actually decode it, there's a whole bunch of stuff you need to do. I won't go through the details, but it's pretty involved if you want to do it properly. And ADS-B is neat because...
Well, it supports extended squitter, and as we were saying before, that's where all the extra information comes in, like flight ID, transponder code. Things like, is the autopilot enabled? Am I on an approach for descent? There's all sorts of intelligent information in there that doesn't come from primary radar. All sorts of state information about the aircraft. This dates back to 1991. 1992 was a movie that we both saw. We didn't meet until about 2 or 3 years ago, but we saw this separately as 10-year-olds. And it's from the movie called Sneakers. And they basically get this universal box which can crack into any system. And one of the things they do is they break into San Francisco's air traffic control system. And ever since then, we've both had this separate idea in the back of our minds that we should do the same thing someday. And moving right along, that's our version.
This is AvMap, so this is the software running when we went up to Sydney Park, I think, set it up. You can make use of this as a more recent version of the software. It does pretty things. If you leave it running for a while, then it builds up and looks like that. You can see all the aircraft coming in, landing and taking off. And here they are taxiing about the runway. This is actually a video, so you can see that there's a plane taking off here, Singapore Airlines Flight 212. And if you zoom out a little bit, you can see more of the activity in the area. This is another one coming in to land. Virgin Australia 825.
Yeah.
825, sorry.
Yep.
And video goes on, but since we're a bit short on time, you can see them taxiing around. It looks pretty cool. But, of course, it looks much better in 3D. And it looks much better when you can click on an aircraft and get a virtual cockpit view, as if you were driving the thing. This is actually a plane coming into land. That's another plane just going across the side there. That's What's that? Someone's taken off there.
Yeah, he's turning to the
Tiger
right.
Airways going to take off in a minute. And the other interesting thing, these pop-ups, there's another communication system that we'll cover very briefly. It's text messaging for aircraft. So the aircraft can talk to their manufacturers, the engines will send reports back to Rolls-Royce, etc. And another system monitors that and actually fuses
And we're going to crash right now.
Boom. Landings are a bit hard on this. What's cool is that taxiing in an aircraft is usually the most mundane thing, but it's so much more exciting when you get to watch it in 3D. This is another example, land Chile flight taking off, heads up into the sky.
Kind of hits a bump in the runway about there.
Off we go. And, you know, if you've got loved ones or wherever coming in from the airport to land, you can just flick this up and...
Yeah. This is all in real time too. Existing feeds that are available on the internet. There's one feed provided by the Australian government. It's got like a 40-minute latency on it. This system here all operates in real time because we control the data. It's 3D, and we get the information with about 500 millisecond latency.
For those of you that saw this last time, this was the setup we were doing on the roof. Science experiment in progress. This is up at the park. We were very happy here because this is not an airborne aircraft and it's not an aircraft on the ground, it's grey. And it turns out that this was actually a ground vehicle.
Yeah, it turns out we found it's the airport, the fire trucks. The fire trucks actually have aviation transponders in there, so when an aircraft crashes and people are burning, they can get the fire trucks there.
And also when they go inspection, there was very heavy rain and I saw these people driving down the runway just to check conditions. Yeah. We were very happy.
And drunk.
This is actually the Queen there, Regal 1. Pluto 7 might have been something to do with Obama. It was about
that was when Obama was here, wasn't it? Yeah.
You can also program them so you can set whatever you like. This is the actual setup on the roof. You've got the USRP laptop, you've got some other radios down there, and other commercial tracker.
And there's foil, so no one knows what it's thinking.
Yeah. This is a camera I've got that looks at the airport. Thanks to the magnets, man. They're keeping it tight. It looks toward the airport, which is there, and you can see planes coming to land, so it's good to correlate the known visual with the information you're receiving from the radar. If you would have seen that video I was showing before, that actually shows you the trails, and it looks cool at night. This is the setup so you can see everything that's going on, correlating visual with the actual coming to land. And we'll skip this. Basically, the whole system has to go through about 5 or 6 computers to get onto the internet, so it's a pretty involved setup. This is New York, this is San Francisco. Rollout here in Australia is much better. Let's quickly talk about those messages so you can bring them up on the web as well. And I like to think that it's exclusively used for reporting on the status of toilets in aircraft.
Yeah, this is the text messaging system that Bala mentioned before. It's actually on a completely separate band and it's got nothing to do with the radar setup. The radar is more for surveillance, so they know where our aircraft are and what they're doing. This seems to be more sort of in-band for aircraft maintenance, aircraft manufacturers and aircraft operators to keep track of the state of their aircraft. Like, for example...
Every time they transmit a message, it drops these little markers.
Nods, yeah. They seem to be quite interesting to read, but you can tell... you can get an idea. A lot of them are engine parameters, a lot of them are fuel loads, weight and balance, and every second message is about an inoperative toilet. So
there's
a lab hard
failure modes. There's hard failures, soft failures, and intermittent failures. And we're assuming lav means lavatory, but we have this in-joke that lav hard.
Yeah, I'll get text.
Here's another lav hard.
I'll get text messages at work that say nothing other than lav hard. And I'll be like, thanks, man.
And you might remember the big A380 disaster where the intermediate pressure turbine took off. That would have sent out a crap load of ACARs.
Yeah, that was the Qantas A380 coming out of Singapore where the engine completely exploded and it took out half the wing and punctured the cabin. They all nearly died, but they didn't.
So that's the aviation component. Just to very quickly finish off, another thing, I won't go into the details, but another thing you can do with it that I've tried is actually hooking the USRP to a satellite dish and pointing it at one of our friendly Optus D1 satellites. This is the Optus space station at Earth Station at Belrose. If you look at that on RFMap, you can see all the usual suspects, Foxtel, digital distribution, all the TV stuff, but there's a lot of other stuff on the satellite as well. And that's actually courtesy of CNET. Spot the satellite modem, they got a crap load of them, so there's plenty of stuff to hunt for. And what do you need? Well, you need a dish, and you need the USRP and some software. This is actually the telemetry signal from the satellite coming through, nice and clear. You can visualize that, extract some data, but that's for another time. Very quickly, we're not going to read this out, but these are some thought experiments. Do not do this.
It will land you in jail.
So whole... These alerts happen, so you could just send one yourself. Because we've been talking about receiving, right? USRP is capable of transmitting.
Yeah, so if you can receive it, you can understand how to reverse engineer the messages and transmit bogus ones, right? So that's what we're talking about in this slide.
So this is like ASCII art, but aircraft marker art. ACARS.
Rolls-Royce is RR, basically the engine guys. Yeah, they've got printers in the cockpit, so you can... Look, I'll have a burger with fries, thanks. You know, like you could send them anything you wanted.
But remember, be legal and be safe. Get a ham license so you know what it's all about. And, you know, all this stuff is all about safety, aviation safety, especially for you and I when we go on our plane trips. So, yeah, thanks for listening.